all the comparisons with humans and with brains, I think it's not the right way to do it.
Yeah, I mean, and so you, like you said, you study now like this multi-agent corporation and goal-directed collectives of cells, actually. And we do see now a bit we're moving in like AI to like like to researchers exploring multi-agent, emergent, or self-organizing architectures. Do you see like the parallels between these natural systems that you study and these like agentic economies or these kind of things that we're building with AI?
Yeah. Well, I think there are two things. On the one hand, I think the way we try to build them is fundamentally not the way biology works. So when we build computational systems, we typically have abstraction layers, we have error correcting codes. The whole point is that the higher level that you want to be intelligent should not care or know about what's going on at the lower levels. When you're programming, you never think that your registers are going to float off because the copper is getting too hot or whatever. You like the whole point of a good computer is to isolate you from all of that. Biology does the exact opposite. It knows that the material is ultimately unreliable. Everything is going to get mutated. You never know exactly how many copies of anything you have. And so in biology, everything goes towards creating algorithms that improvise. They don't take the information literally that they have; they improvise, and this is true for memories in our brain as it is for DNA. Embryos don't just do what the DNA says; they actually interpret these things, and that's what gives them the plasticity to do new things. So this idea of emphasizing the saliency of information and the plasticity of its interpretation, not the fidelity, not the error correcting part, is very different, right? And I think until we start building that way, we're not going to be able to reach what biology is actually doing. But there's a flip side to this, which is that I also think that this notion that systems do what we build them to do, and this old idea that we all learn in computer science, that you have an algorithm, the algorithm does exactly what you want it to do, and it's a dumb machine, and it's only going to do what you tell it to do. This is what we're now finding is an extremely limiting perspective, and basically, and when we have some very minimal systems that are showing us how this is actually incorrect, and if those minimal systems are doing it, then I'm sure that complex AIs and all of these things are probably doing it too. There are lots of novel properties, and I don't just mean complexity or unpredictability. I mean things that are recognizable by any behavioral scientist. Okay, so protocognitive competencies that arise in systems not because of the algorithm that we put in, but despite the algorithm. It arises in the spaces between. It arises in the things that the algorithm does not prevent them from doing. And so from that perspective, it turns out we are also very bad at knowing and being able to predict what's going to happen, because we don't know where novel collective intelligences get their goals. We have no idea, right? In biology, you can sometimes blame it on evolution, but for these things, we don't know. And so just because we think we've engineered it in a certain way, and we're watching for certain kind of output, let's say linguistic kind of output, that may not be at all where the intelligence is going or what it's doing, and it may give actually very little clues to what's going on.